So the key to multiplying polynomials is to distribute and simplify. One of the most common ways to multiply polynomials is the FOIL method, which most of you might have heard in high school. The first, outside, inside, and last. So if I have A plus B times A plus B, I'm going to multiply first, which is A times A. That would give me A squared. And outside, which would be those two, A times B. Inside, which should be those two, AB. And the last would be B and B. So I will get B squared, B times B. So that would simply give us A squared plus 2AB plus B squared. Now that is the FOIL approach that we know of. The same answer can be obtained with distribution and simplification. What do I mean by that? Suppose we have A plus B times A plus B. I can write this as the first term, A, and distribute it to the entire second factor, which is A plus B. In other words, I'm going to take A and multiply by A plus B. Then I'm going to take B and multiply by the second term. So I'll have B times A plus B. And now I could distribute. So if I distribute the A times A is A squared, A times B is AB, B times A is the same as A times B, so I would have AB plus B times B, which is B squared. So we will end up getting A squared, AB plus AB is 2AB plus B squared. And as you can see, the answer is the same. Even though FOIL is a great thing, the distribution and simplification approach is the most effective approach because it will help you understand the concept of factoring better also. So the key to multiplying is to either distribute and simplify or to just FOIL. Other things to keep in mind when we are multiplying polynomials: we have to multiply the constants together. If we have identical bases, would simply mean we have to add the exponents or the powers. And we keep track of signs. That is, positive times positive equals positive. Negative times positive is negative. Positive times negative is negative. And negative times negative is positive. And lastly, we should never forget to simplify. Okay, so here we have two monomials. So that is a monomial because it has one term. That is the second monomial because it has one term. But keep in mind, monomials are polynomials. Now, when we multiply, we have to multiply the constants, the signs, and the variables. I have a negative here, positive in front of 4, so negative times positive is negative. 6 times 4 And lastly, multiplying the variables, I have a times a. You can see how I grouped the numbers and the constants, and I'm keeping them separately. It is a great idea to do it this way so that you don't make any mistakes. So 6 times 4 is 24. Identical bases, so we add the powers, which is 1 plus 1. We have a squared. So in the next problem, we have 7.1 xy squared z raised 11, 10 xy raised 7 multiplied by z. So a case like this is quite easy. First, I have to multiply the numbers. So 7.1 multiplied by 10. Then I can multiply the x's, x times x. Then I have to multiply the y's, y squared times y raised 7. Then I multiply the z's, z raised 11 times z. 7.1 times 10 is 71. X times x is x squared. Y squared multiplied by y raised 7. The bases are identical, so we add the powers. 2 plus 7 is 9. So we have y raised 9. Z raised 11 multiplied by z. Bases are identical, which is simply z. Add the exponents. 11 plus 1 is 12. So the answer is 71 x squared, y raised 9, z raised 12. So the key here is to distribute. If I distribute the term that is outside, which is negative 6xy, I will have negative 6xy multiplied by the first term, which is 4x, plus negative 6xy multiplied by y. So in the first term, right here, negative 6 times 4 is negative 24. X times x is x squared. There is a y in the first part, but there is no y, so y times 1 would be y. In the second term here, we have a constant, which is negative 6. There is an x in negative 6xy, but there is no x in the y term, so x times 1 would simply be x. And lastly, y times y is y squared. So what we would have is negative 24 x squared y minus, why do we put that minus? It's because plus times minus is minus. So negative 6x y squared. So the problems are getting a bit more complicated. We're adding, we were at monomials, now we are getting into monomials and trinomials. So we want to multiply and simplify if at all possible. So this is a case where we simply distribute and try to simplify. So the term that we are trying to distribute would be negative 4ab. So negative 4ab multiplied by the first term, which is x times a squared, plus negative 4ab multiplied by the second term, which is y a squared, plus negative 4ab multiplied by negative 3. So there aren't any x terms, there aren't any constant terms in those two, constant terms and x terms, I mean in common between the two terms in the highlighted term. So I could write it as negative 4x. There is an a and a squared. If I multiply, I would get a cubed. There is a b in negative 4ab, and there is no b in xa squared, so b times 1 is simply b. So in the second term, we have negative 4 times 1, which is negative 4. y times 1, we would simply have y. A times a squared is a cubed. B times 1 would simply be b. The last term, negative 4 times negative 3 is 12. There aren't any a's or b's in that negative 3, so we would simply have ab. If we manipulate the signs, we would end up having minus 4x a cubed b minus 4a cubed y b plus 12ab. Keep in mind we can switch the order when it comes to multiplication and addition, but we can't switch order if it is subtraction or division. So that's something we have to keep in mind. So this is another interesting problem where we have two factors. The first one is a binomial, so 2 terms. The second one is a trinomial. It has 3 terms. The idea here is to distribute, then simplify. So we take the first term and multiply it to the entire x cubed minus x plus 2. So we would have 2x multiplied by x cubed minus x plus 2. Then we take the 3 and we multiply by x cubed minus x plus 2. Then we distribute and we try to simplify. So 2x distribute in, you have 2x times x cubed minus 2x times x plus 2x times 2. There is a plus sign in the middle, so I'm going to put a plus sign. It is good practice to distinguish the first term from the second, but if you follow it, you don't have to do this. I'm going to distinguish it by putting a square bracket. If you understand the process, that square bracket part is not needed. I'm doing it so that you don't make mistakes. So distribute the 3, we have 3x cubed. 3 times negative x is negative 3x. 3 times 2 is 6. 2x times x cubed would be 2x raised 4 minus 2x times x is 2x squared. 2 times 2x is 4x. And since it is a positive sign, we distribute positive 1, so we would have positive 3x cubed minus 3x plus 6. Now we have to combine like terms. So we don't see any x raised 4 terms except that 2x raised 4. So we have 2x raised 4. There is one x cubed term there, but no other x cubed terms, so plus 3x cubed. We have only one x squared term, which is right over here, and it bears a negative sign, so negative 2x squared. There are 2 x terms. One of them is 4x, the other one is minus 3x. So 4x minus 3x is positive x. And there is only one constant term, which is 6. We can't simplify it any further because the terms are completely distinct. And as you can see, when I write it in decreasing powers. So x raised 4, x cubed, x squared, x, and the constant term. That is just convention. We like to write things in decreasing powers of x when it comes to exponents. Polynomial functions. So we are simply going to distribute that 7x squared y cubed, 7x squared y cubed multiplied by minus 3ax plus or we can put minus, it's entirely up to you. Minus, so plus in front of 7, minus in front of 4xy. So I combine it and put a minus, 4xy plus 7x squared y cubed multiplied by z. 7 times negative 3 in the first term is negative 21. There is an a by itself, so I'm going to put a first. X squared times x is x cubed. Then we have y cubed. Negative 7 times 4, 28. X squared times x, x cubed. Y cubed times y, y raised 4. Plus 7x squared y cubed multiplied by z. They should be multiplication, not addition. Okay, so we're going to multiply and simplify if at all possible. So the key to doing this is to distribute and simplify. So I'm going to pick the first polynomial, and I see x squared, 4x, and minus 7. So first, I'm going to multiply x squared with the entire factor. So I have x squared multiplied by 8x squared plus 9x minus 7. Then I am going to take 4x and distribute it to the entire factor. So 4x multiplied by 8x squared plus 9x minus 7. And lastly, I have negative 7, which would be that term, and I'm going to distribute it in. So negative 7 multiplied by 8x squared plus 9x minus 7. Now it's all about distribution and simplification. So the first term we have to distribute x squared. So 8x squared times x squared is x raised 4 plus 9x times x squared is x cubed minus 7 times x squared is 7x squared. There is a plus in the middle, so I'm going to put plus. We have 4x times 8x squared, which is 32x cubed. 9x times 4x is 36x squared. Negative 7 multiplied by 4x is negative 28x. And lastly, since we have a negative, we have to carry that negative through. So negative 7 multiplied by 8x squared is negative 56x squared. Negative 7 multiplied by 9x is negative 63x. Negative 7 multiplied by negative 7 is plus 49. Now we have to combine like terms. The only x raised 4 term is the very first term in the polynomial. So we would have 8x raised 4. And next we have to gather all the x cubed terms. And we have an x cubed term there, x cubed term there. So 32x cubed plus 9x cubed is 41x cubed. Then we have to gather all the x squared terms. I have negative 7x squared, positive 36x squared, negative 56x squared. You are welcome to use the calculator to add those constants, but if you add them all together, you would get negative 27x squared. And The next step would be to gather all the x terms, which is negative 28x and negative 63x. If I combine those together, I would have negative 91x, and the constant 49 is by itself. And that would be the final answer. Okay, so same process. I'm going to take the first factor, which is a trinomial, which is right here. And I'm going to take each of its terms and I'm going to distribute it in the other polynomial that I have. So 7x cubed y multiplied by 5x cubed y plus 4xy plus 8x minus, because there is a minus sign, 4xy multiplied by 5x cubed y plus 4xy plus 8x. And we have 8, so plus 8, 5x cubed y plus 4xy plus 8x. Now we just have to distribute, and the last step would be to simplify. So when we distribute the first term 7x cubed y inside the trinomial, we would get 35 x raised 6, y times y is y squared. 7 times 4 is 28, x cubed times x is x raised 4, y times y is y squared. 7 times 8 is 56, x times x cubed is x raised 4. There isn't a y that's common between both terms, so we simply have y. Since there is a negative, that negative has to be carried through. That is one of the most common mistakes that folks make. They don't carry through that negative as they multiply or as they distribute. So negative 4xy multiplied by 5x cubed y would be negative 20 x raised 4 y squared. Negative 4xy multiplied by positive 4xy would be negative 16 x squared y squared. Negative 4xy multiplied by 8x would be negative 32 x squared y. Then we distribute that 8 in, so we will get 40 x cubed y plus 32 xy plus 64x. Now we just have to go and hunt for common terms. So the common terms, clearly 35x raised 6y squared is by itself, so we'll leave that as is. X raised 4y squared, so there is 1, 2, and that's all, which would give us 8x raised 4y squared. We have 56x raised 4y. Search through to see if there is a term of that sort. I don't see it, so it would be 56x raised 4y. The next term is negative 16x squared y squared. Search through the remaining expression to see if there is a term x squared y squared. I don't see it, so negative 16x squared y squared. And negative 32x squared y, there isn't another x squared y term. 40x cubed y, there isn't another x cubed y term. 32xy, there isn't another xy term. And lastly, we have 64x. So same process as always. We take the 4x squared and multiply by x squared minus 2y squared. minus 5y squared multiplied by x squared minus 2y squared. Now we distribute 4x squared times x squared is 4x raised 4. 4x squared minus 2y squared is negative 8x squared y squared. Negative 5y squared multiplied by x squared is negative 5x squared y squared. Negative 5y squared multiplied by negative 2y squared is positive 10y raised 4. So the middle two terms, well, let's start at the beginning. There isn't another x raised 4 term, so I'm going to leave it as is. X squared, y squared, there are two terms. One is negative 8x squared, y squared. The other is negative 5x squared, y squared. If I combine them, I would have negative 13x squared, y squared. The last one is y raised 4, and it is by itself. So we are going to enter into something important, which is called a special product. What is a special product? There are certain products in mathematics which people have simplified and just say, okay, you can just use it as a formula or an identity. So that's what we mean by a special product. It means a formula. So I'm going to write the first formula here, but before I write the formula, I want you to notice I have 3xy here. I have the same term there in the two polynomials. Likewise, I have 2b here. I have 2b there, the same term. But one of them has a negative sign, the other has a positive sign. So if that is the scenario, then here is the special product. So we would have sum m plus n, m minus n, would simply reduce to m squared minus n squared. That is the formula. So you can verify this by distributing and simplifying. All I'm saying is it is not necessary because it is a special product. It'll always be m squared minus n squared. So in this problem, m is 3xy and n is 2b, and the signs are different. One has a plus, the other has a minus. You may say, well, I have m minus n first and then m plus n, but keep in mind, when we multiply, the order doesn't matter. So m minus n times m plus n is the same as m plus n times m minus n. So the identity says that the answer should equal to m squared minus n squared. So m is 3xy. So I am going to have 3xy squared minus, in the middle, n is 2b squared. Now we could use the concept of exponents. If we have a square, we square each term. So 3 squared is 9, x squared, y squared, minus 2 squared, which is 4, and b squared. And that is the answer. So once again, we have m minus n and m plus n, identical terms and differing signs. So we have m, n, m, n, and we know the answer has to be m squared minus n squared. So we would have 2x squared minus 1/3 squared. Using properties of exponents, 2 squared is 4 and x squared minus Again, properties of exponents. Apply the exponent to the numerator. 1 squared is simply 1. 3 squared is 9. The same process. The only difference in this problem is that m is 7ab, n is 3c, differing signs in the middle. So we would have m squared minus n squared. So 7ab squared minus 3c squared. Apply the squared to each term using properties of exponents. 7 squared is 49, a squared, b squared, 3 squared is 9, and c squared. And that is the answer. So here is a complicated problem, but earlier I mentioned that I like to use square brackets and parentheses wherever necessary. And you can see the author of the textbook has the same practice also. But then again, it is a common practice to use square brackets, parentheses, so that we know or we can distinguish terms properly. So in this problem, we have this giant expression, and we are squaring it. We are raising that expression to the power of 2. Now, this might look extremely complicated if we do not know the identity. But what you should realize here is that there are 2 terms. That term, let me just call that as A, and that term as B. So I see a minus in the middle, and the identity is A minus B squared is simply A squared plus 2AB plus B squared. That is the final answer. Sorry, minus. In a similar manner, instead of a plus sign in the middle between A and B, if I had a positive sign, A plus B squared, the only thing that would change is the sign of the term 2AB. So I have plus B squared. So if it is minus here, minus there, positive there, positive there, the A squared and B squared term will always be the same. So A is x squared plus 4x. So A squared B is 6. So we'll keep that. Since I see a minus in the middle, I'm going to put minus 2. A is x squared plus 4x. B is 6. Common mistake. People would put it as negative 6. It is not negative 6. We have already accounted for that negative sign in the formula or the special product, which is right here. And that negative is the same as that negative. We're already accounting for that negative sign. So I would have B, which is 6, and lastly, plus 6 squared. Because A is x squared plus 4x and B is 6 squared. So the answer here is x squared plus 4x squared minus 2 times 6 is 12 multiplied by x squared plus 4x plus 6 squared is 36. Now this can be simplified further. I'm not going to do it because we have to do something called the greatest common factor. If we did that, we can simplify it nicely. For now, this answer is sufficient. So that is A, I could call it M. If we have to distinguish, let's just call that M, and we'll call that N. And M plus N squared, if we look at the special product here, instead of A, I used M, instead of B, I used N. What does the formula state? The formula states I have to square the first term, which is 2A squared plus 4A squared, plus, because there is a plus sign in the middle, 2 multiplied by the first term, which is 2A squared plus 4A, multiplied by the second term, which is N, 1, plus N squared, which is 1 squared. Now, let's just have 2A squared plus 4A squared, plus distribute that 2. We have 4A squared plus 8A. Lastly, we have plus 1. Now, common mistake, and I believe most students will make this mistake, writing, put it as a caution, 2A squared plus 4A squared as 4A raised 4 plus 16A squared. In other words, applying the square to each of those terms that are inside to get the one on the right hand side. That is incorrect. So how would we go about doing this? So if you look at this term, we can say 2A squared as M and 4A as N. And what we have here is M plus N squared. It is a special product that we had already seen. So if I use the identity, which is M plus N squared, I'll write it again, is M squared plus 2 times M times N plus N squared. So what is M? M is 2A squared. So 2A squared, I'm going to square that, plus 2 times M, which is 2A squared, N is 4A, plus 4A squared. And that is the expanded version of that term. We still have 4A squared plus 8A plus 1. Now we could simplify. 2 squared is 4. A squared, you're squaring it again. Properties of exponents, I'd get A raised 4. The second term, 4 times 2 is 8. 8 times 2 is 16. A squared times A is A cubed. Plus 16, because it's 4 squared, 16A squared, plus 4A squared, plus 8A plus 1. Now we try to simplify. Well, there isn't an A raised 4 term, so we simply have 4A raised 4 plus 16A cubed. We don't have another A cubed term. We can combine 16A squared and 4A squared to get 20A squared plus 8A plus 1. And that would be the final answer. So, going to call that M and that entire term as N. And the identity that we're going to use is m minus n squared, which is m squared minus 2 times m times n plus n squared. So m is 5, so 5 squared minus 2 times m, 5, multiplied by n, 3b minus a, plus n squared, which is 3b minus a squared. 5 squared is 25. 5 times 2 is 10 times 3b minus a. But if you look at the last term looks like another m minus n scenario. So I can write that part as m squared, which is 3b squared, minus 2 times m times n, plus n squared, which is a squared. Now I can distribute and simplify. 25. If I distribute that negative 10, I have minus 30b plus 10a. All I have is a positive sign, so I can distribute that positive 1. So I have plus 3b squared minus 6ab plus a squared. Sorry, that's 9b squared. It's bad algebra. So 9b squared. So the answer is a squared plus 9b squared minus 6ab plus 10a minus 30b plus 25. You may say, or you may ask, well, why is he writing that way? Keep in mind, polynomials, we have to write in decreasing powers. And not only that, in this problem, we have a and b. So I'm just putting it in alphabetical order. So a squared, power of 2, b squared, power of 2, ab, different bases, power of 2 though, 2 terms. Then comes a, then b, and finally the constant. So here is an interesting case where we have x plus y multiplied by x minus y multiplied by x squared minus y squared. We know m plus n multiplied by m minus n is simply m squared minus n squared. So all of that would simply reduce to m squared, which is x squared, minus n squared, which is y squared. And I'm multiplying that by x squared minus y squared. So what I have now is x squared minus y squared multiplied by x squared minus y squared. And we all know 2 times 2 is 4, 5 times 5 is 25, or 5 squared. So x squared minus y squared multiplied by x squared minus y squared is x squared minus y squared whole squared. Now that is another special product. If I call that as m and that as n, m minus n squared, that goes back to the special product that we did in the previous problem. So we will end up having m squared minus 2 times m times n plus n squared, which is y squared squared. Properties of exponents, x squared and you square it, we have x raised 4 minus 2 x squared y squared plus y raised 4. So this particular problem is tricky. It might look very complicated. Now, x minus 1 raised 4 is x minus 1 multiplied by x minus 1 multiplied by x minus 1 multiplied by x minus 1. Now, you may argue, well, I'll just sit here and FOIL. Well, good luck with that. It's going to take a long time, and you may make mistakes. So what is an easier way to do this? We should realize that x minus 1 raised 4, I could write it as x minus 1 squared, which is the same as saying x minus 1 squared multiplied by x minus 1 squared. They're all one and the same. But what do we know about x minus 1 squared? That is of the form m minus n squared. We're going to use the identity that we used in the previous problem. So what is m minus n squared? M squared minus 2 times m times n plus n squared, which is 1. Don't forget the square that we have. And that gives me x squared minus 2x plus 1 squared. And now you would say, okay, how would we go about writing this out? Well, it's going to be harder if you wrote it as x squared minus 2x plus 1 multiplied by x squared minus 2x plus 1. It is the same thing. Now, earlier today, we did a problem or couple of problems where I FOILed it out or distributed the terms and then simplified. You are more than welcome to do that. But here, I'm going to use a special product to demonstrate how, you know, sometimes life could get easier. So I'm going to call all of that as m. And the 1 as n. Now that is of the identity m plus n squared, which is way back over there. We know m plus n whole squared is m squared plus 2 times m times n plus n squared. So if I use that identity here, m squared is simply x squared minus 2x squared minus 2 times m times n, which is simply 1 plus 1 squared. And that would give us x squared minus 2x squared. Distribute the 2 minus 2x squared plus 4x plus 1. Now you can realize that x squared minus 2x whole squared is the same concept of having m and n. So what is m minus n squared? I'm going to rewrite that part using the identity m minus n whole squared. That would be m squared minus 2 times m times n plus n squared 2x squared. Keep in mind that we have terms negative 2x squared plus 4x plus 1. Using properties of exponents, x squared squared is x raised 4. 2 times 2 is 4. X squared times x is x cubed. 4x squared. The next term is minus 2x squared plus 4x plus 1. And if I simplify that, I would get x raised 4 minus 4x cubed. 4x squared minus 2x squared is 2x squared plus 4x plus 1. So we have x plus 3, x minus 3. That is of the form m plus n, m minus n. We know from earlier the identity m plus n multiplied by m minus n is m squared minus n squared. So m is x, so x squared, minus n is 3. We have 3 squared, but don't forget that we have another term out here that is x squared plus 9. So we end up having x squared minus 9 multiplied by x squared plus 9. Again, this is of the form m minus n multiplied by m plus n. So we would have m squared, which is x squared squared, minus n squared, which is 9 squared. X squared squared is simply x raised 4 minus 9 squared is 81. So the answer is x raised 4 minus 81.